Hey guys, welcome to Geospatial Support. Today we are going to do fault detection using Sentinel-1 and next time using Sentinel-2 using Google Earth Engine and ArcGIS Pro. I will explain everything on Google Earth Engine and explain that in much more detail in ArcGIS Pro. So first we will do Sentinel-1 in part 1, which is a SAR imagery, and Sentinel-2 in part 2, which is a optical imagery. So first of all, Sentinel-1, a little bit of its introduction, SAR introduction. It's a European satellite agency and it's a SAR imagery. It uses orbit passes, which is generally, if the satellite is going from north to south, it's descending path, and if it's going from south to north, it's ascending path. So you can visualize your same area in two different directions. It works in C-band, which is a microwave range, in 5.6 centimeter wavelength. It uses mainly two wave polarization, vertical and vertical horizontal. To detect flooded areas, mainly water bodies, VH works really better as compared to vertical. Sorry. Its temporal resolution is 12 days, which is really good, and it works in day, night, even it is cloudy or clear, there is even precipitations going on, it will work. And next, just to get an idea of SAR imagery, that's how it will look like. And mainly the water bodies are below minus 25 dB, which is a unit of decibel, and higher values show much more in a bright way, where the signals are not that much lost. And our water area, there is a lot more scattering, so signals are lost. So by just comparing pre and post imagery, like here, this one is pre-flooded imagery, this one is post-flooded imagery. Here you can see, just by looking at it, there is water and there isn't water, and we can do different stuff to make it much more visible, to extract this area. So these methods are simple threshold method, like we can just apply a threshold of minus 25 and visualize it, or maybe take their difference and then apply the threshold to get the flooded areas out. So one drawback of this one is it will also input noise into it, which is kind of in SAR language speckles. So we can deal with it by decreasing the resolution a little bit, and it will absorb the noise, small noises. Or we can just do unsupervised classification, make a composite of maybe pre-post by taking their difference, by multiplying them, taking their ratio, and then make a composite of it and do unsupervised classification on it, and it will also work. And the next thing is CCD-PC method. It's by taking pre and post imagery coherence and then apply PC on it. It will remove a lot of noise from it and make the visualization better. But this method decreases the resolution a lot, and it mainly works for desert areas. It will not work in vegetated area or maybe in an agriculture zone, it will not work that well. So let's carry on to ArcGIS. No, maybe first on Google Earth Engine. So that's our study area. It's Spain, some area of Spain, Valencia, beside Valencia. So that's going to be our code. This is our geometry, and that's going to cover our study area. These are the dates for pre-flood imagery range and post-flood imagery range, and the polarization that we are going to use, and the orbit pass. The orbit pass is optional. Both of them will work. It just depend on the on the frame of the imagery, or maybe just on the visualization. You can try both of them, and rest of the code is just importing and for visualization and taking difference, multiplication, ratio, and just to make a composite and doing unsupervised classification, and then export them all. So let's run it. So that's pre-flood imagery, and that's post-flood imagery. I have already applied the threshold of -25 decibel. So if you want to see the original imagery, it will kind of look like this. That look like this. It will have all of the texture and everything, but just to make it easier to see the only the water bodies, we can apply the threshold, and here you can see it's easily visible, and by checking the ratio it will also make it much more visible. We can try multiplication. There it is, and we can subtract it, and it will also show the flooded areas. So now if you go over the task, just run these and it will export them all. There is pre-flood, post-flood imagery, and this composite that contain all of these images. There it is, and you can also visualize it in unsupervised classification. And here this yellow area is showing deep flooded area, and blue areas is showing shallow water body. Like if I show it to you like this. So let's download these images and go to ArcGIS Pro. Here it is. This one is going to be pre-flood, that's post-flood, and before we start on, we will just remove this water body area and clip out our study area. Okay, extract by mask, and let's name it pre-flood, and similarly do the next. There, both of them are ready now, and it's much more easier to visualize them without all of that water. And now we will focus on But first we will focus on the threshold method. We will just take their difference by using raster calculator. Just subtract pre-flood from post-flood and run. Now here, by taking the difference, it's just simple math. These flooded areas will show much more negative values as compared to the pre-flooded area, so it will give us much more bright results because the resultant value is going to get positive. So before we apply the threshold, let's just dim the net noise, this speckle noise. For that we will take an aggregate and input self factor. I think 5 is good. It will decrease the resolution, but still it will work. It will take out the noise. So let's see. Okay, now it's good, much better. You can try different values, 5, 3, whichever one works for you. So now if we check over here, it's showing around 15. Yeah, 15 is good, or maybe we can try 10. Let's try 10. Okay, let's rename it flood area and run it. It will give us a binary imagery which we can use. There you go, that's our flooded area. Now we can just polygonize it. And select rest of the area and delete it. There you go, that's your flooded areas. Let's just make them blue, easy to visualize. No, it's the other way around, and that's good. There you go, your study area is extracted, not that much noise. If you haven't applied that aggregation, you might see a lot of similar like this one, this type of noise a lot. So now the next step we are going to do is by classification. So for that, let's just keep it simple. We will not take a lot of product imageries. We'll just take pre-flood, post-flood, and maybe their ratio difference, and just apply the classification on it. Maybe we can just try one more thing: pre-flood divided by post-flood. Let's just take this one as well. Okay, so these are going to be our composite imageries, and one thing, I have just inverted this one. Okay, so let's click composite and run. Okay, so the composite is complete. It will make the visualization much more better, like the flooding areas in purple, rest of the areas in yellow. So we'll just apply a simple unsupervised classification, pixel based. Here just set default schema, and next ISO cluster. It's not that much better as compared to k-means. It also take much more time, but let's see. 10 classes are good, rest of the stuff is good. Okay, run. Okay, it's now complete. So here you can see it have given us the flood areas in much more better way as compared to the threshold method. Not that much noises, and let's see which one number does it goes for. And this one is 0, just 0. Okay, that's why I don't like ArcGIS Pro classifier. Takes a lot of time on everything. Okay, now it's complete. We'll just polygonize it and extract this 0, or maybe we can just do that. Let's take the value out, that's equal to 0, and remove rest of the values, turn them off, and let's compare. Okay, you also go off. So it does have noise, a lot of noise, but I think by also aggregating that one it will improve. Like we will have to deal with this noise. So the only one condition to deal with it is just aggregate before you do the composite, or just aggregate it from the source, from pre and post imagery, and do the rest of the stuff. So that's going to be from classification, and this one is from threshold method. And if compared, threshold method do not have that much area covered for flooding as compared to the classification, but on the other hand classification also have a lot of noise. So whichever one works for you, you can choose it. And just that's it. I will see you on the next video.